Okay, so today we are graphing systems of equations. Go ahead and put your name on here. It's currently first hour. So, a system of equations, which is what we are going to be covering for the next, I can't remember if it's 7 or 8 lessons, but all of Unit 3 is a collection of 2 or more equations. So a system of equations is 2 or more equations. So everything that we've done this year so far, all of Unit 1, we solved one equation. All of Unit 2, we graphed one equation. Now, Unit 3, we're going to combine together graphing and solving, but there are always going to be 2 or more equations. In Algebra 1, we're going to focus on just 2 equations. In Algebra 2, you will see systems where you have 3 equations or more. The solution to a system of equations is the point that makes both equations true. So instead of just one or the other, it has to make both equations true at the same time. Okay. Just like back in Unit 1, when we were solving equations by hand, and we could get no solution, one solution, or infinite solutions, that is going to happen today as well. So you are going to end up graphing 2 lines, and they're either going to end up never crossing, crossing once, or always crossing. So if you have 2 lines that never cross each other, you are going to have no solutions, because they're never going to cross each other, so there's never a point that's on both of your lines. What type of lines are those? Parallel. So you want to put a little note to yourself that those are parallel lines. Okay. Most of the time, what's going to happen is you're going to have 2 lines that cross each other in one place. And the point where they cross is going to be your solution. And you're going to write your solution as an ordered pair, x, comma, y. Okay. And then every once in a while, and we put 1 on your notes. I don't think there's even any on your assignment because it's kind of goofy for it to happen and for us to make you do it. Every once in a while, you will have 2 lines that are crossing each other always. If 2 lines are always crossing each other, that means they are the same line. So if I graph a line, and then I graph my other line, and it's literally right on top, I get 2 lines that are the same line. That is how I would have infinite solutions. We're going to do 1 on your notes so you guys can see that that's a thing that might happen. But that's not a very realistic thing that might happen in the real world, because you would be able to tell before you even graphed it if you saw the equation and you saw that they were the same. Okay. Any questions about those 3 concepts? Okay, for today, all of the equations that we give you guys are all going to be in slope-intercept form. Y equals mx plus b, which is the easiest form that you guys graphed from. It's the thing that you guys were the best at last unit. Tomorrow, just going to announce to you tomorrow, Wednesday when I see you, some of them are going to be in standard form. Not all of them, but some of your lines are going to be in standard form. So we'll review how to graph those. And then Thursday, Friday, so Friday for you guys, they're all going to be inequality. So that's where we graphed a line and then shade it on one side or the other. So that's the plan for this week. You do not need to learn how to graph anything new. You already know how to graph all these things. You're just graphing 2 lines at the same time. So let's move down to our examples. Our first one we've got is y equals 4/3 x minus 5. Let me grab two different colors of pen so you guys can see the difference between the lines. So I'm going to do this first one in like pinky. So we're going to start our graph at -5. And we're going to graph a slope of 4/3. So we go up 4, right 3, up 4, right 3. We can go ahead and connect those. I recommend connecting your first line before you start trying to graph your second one, because otherwise you might get confused as to which dots go to which line. Okay, for our next one, we are going to start at a y-intercept of 2. What number is in front of this x here? 1. So there's an imaginary -1x there. So my slope is -1, so I go down 1, right 1, so on and so forth. Something happened wrong. That first one I only went up 3/3, up 4/3, up 4/3. I was like, this isn't crossing in the right spot. Okay. I was a little off on that first one. That's my bad. It's a very Monday mistake of me. Let me white out some of that extra stuff. Sorry, video. And sorry, first hour. There we go. Alright. If you counted correctly, unlike me, you should have gotten your two lines crossing perfectly at 3, -1. So this point right here is where they cross perfectly at 3, -1. And that is your solution. When you write your solutions, x always needs to go first. Okay. Any questions on that first one? Okay. Let's look at the next one then. So we've got y equals 3x plus 4 and y equals 3x minus 2. What do you notice about those two equations? They both have the same slope. So let's go ahead and graph them and see what happens when they both have the same slope. So I've got 3x plus 4. I'm going to start at 4. Graph a slope of 3/1. So I go up 3, right 1. I can also go down 3, left 1 a couple times. Okay, for our other one, 3x minus 2, we'll start at -2. We'll do a slope of 3, so I'll go up 3, right 1 a couple times. I can also go down 3, left 1 once. Okay, when do these lines cross? Never. How many solutions do they have? None. So we're just going to write down no solutions on the line. So if your lines never cross, you still need to graph them, but then your answer is that you have no solutions. Hey, any questions on either of those problems so far? Okay, flip this over then. We've got 2 on the back. We've got y equals 1/2 x minus 2 and y equals x plus 1. For this one, we'll start with that 1/2 x minus 2. So I'll start at -2. going to graph a slope of 1/2. So I go up 1, right 2, up 1, right 2, up 1, right 2. With your first line, you always need to make it go all the way to the right and all the way to the left, because I have no idea where these are going to cross yet. So I'm going to go down 1, left 2, down 1, left 2, down 1, left 2, as far as I can. Alright, then I want to go start working on my other line. So my other line is y equals x plus 1. We already discussed if there's no number in front of x, it's an imaginary 1. So I'm going to start at a y-intercept of 1, and I'm going to graph a slope of 1. So I'm just going to start going up 1, right 1. And as I do this, my lines haven't crossed. It's going to be really tempting to say, well, if my lines aren't crossing, then it's no solution. Do these lines have the same slope? No. This one has a slope of 1/2, this one has a slope of 1. If they do not have the same slope, at some point, they are going to cross. So what that means is I need to keep going down and to the left as well. So down and to the left. You have some faith that they're eventually going to cross, and they do. So those ones cross down at the very bottom left-hand corner. There's a reason why it's important to be very delicate and exact when graphing. You gotta use a ruler. You gotta draw your points all the way across your graph. So these ones cross at -6, -5. So my solution is -6, -5. Okay, very, very last one. What do you guys notice about those equations? They're the exact same equations. So if they're the exact same equation, they're going to get graphed in the exact same spot. So let's graph one of them. Start at 4, slope of -2. If I were to graph the other one, I would do the exact same thing. Start at 4, slope of -2. I would connect it. I'm going to try to draw it on top of it. So you guys can see it's the exact same line. If you have the same line that gets graphed twice on top of itself, then that is going to be infinite solutions. Alright, I did not put an infinite solution one on your assignment. I did put, I think, one no solution one, and all the rest of them have solutions. So, any questions right now? Groovy. Let's go ahead and glue these in, and then we'll have about 15 minutes to work on our assignment today. Mondays, when we have to make pockets, always feel like we don't have enough time. We'll see how long this assignment takes. So, fold this down. I'm going to leave the back of my quick write page open just in case I need it to finish up quick writes. But then from here, I'm going to glue front, back, front, back, front, back. So, glue your notes down. And I will be around with your assignments momentarily. Let's stop this video. Bye, video.